Hey guys, it's Zilch here. Maybe not. Today I'll be talking about my latest addition to the 20 Games Challenge, Sudoku. As you can see here, the Sudoku implementation started off as a simple program on my phone, coded in the Python language in the app Pythonista. This was later ported to the engine or framework Love2D, which uses the scripting language Lua. My algorithm works by generating the Sudoku boards through brute force. First, I create a 9x9 2D array, a grid full of zeros and a function called create2darray. I scan each of the 81 cells row-wise inside. For each cell, I start off with an array filled with integers 1 through 9 called choices, representing all the cells in Sudoku. Then I sweep out in a cross-section both vertically and horizontally across the entire board in a function called cross-sweep, and check the entire 3x3 sub-quadrant in a function called quadrant sweep. Each function takes away possible choices, and from the remaining choices I randomly pick. The problem is collisions, where there are no choices left. If that happens, then I erase the entire row and try again. If that happens more than a certain amount of times, I consider the board invalid and restart the entire process from zero until I get a successful board. Now for the graphical user interface, our GUI. This also started off in Python and Pythonista. In my last video where I showcased Minesweeper, I had to manually calculate the positions of the UI elements and buttons. This was an extremely tedious process since Love2D doesn't have a default GUI, our UI system. There are many implementations of this, as offered by the awesome Love2D page, but I decided to make my own. How exactly does it work? What is its purpose? It's a space partitioner at its core. It divides the screen into chunks based on its specified area, partitioned into areas consisting of x1, y1, x2, y2, are the relative dimensions of the parent area through an implied width or height percentage, are the percentage of the minimum side of the parent. The minimum percentage overrides the width and height percentage, and those two width and height percentages overrides the basic area. Internally, it uses an index tree and/or a dictionary that details connections between a series of nodes or indices and the child indices they are connected to. Each addition of an area returns the index added. These partitions of an area also define the size of the widgets. There are only 2 widgets currently available, and the ones that I deemed the most essential and basic: buttons, which can hold images, text, and have basic interactability, and scroll wheels and slash progress bars. Buttons could serve as labels, text fields, check buttons, radio buttons, and text scroll regions when paired with the progress bar. Here you can see the evolution of my Sudoku implementations, going from the initial space partitioning of the board, then to a simple scene system that's black and white, then adding tweens for juice. And that is all. Thank you for listening to the latest part of my 20 Games Challenge. Hopefully next time I'll make this faster, along with the improved GUI system. Don't forget to like and subscribe.